I'll record again. Yeah, I realized when I started talking to myself, I asked a question and then no one replied. I was like, oh, whoops. Okay, so let's draw out these unit circles. Just draw a circle with a set of axes through it. Okay, it doesn't have to be perfect, but what I like to do is draw the circle first and then draw the lines through it like so. Okay, that's easier. What we're going to do now is we're going to actually locate where these angles are on the unit circle. Okay, so what we need to do is we need to break this up. Now we have a look at the denominator here. And I noticed that. Everything good?
Yeah, I'm just encouraging some reluctant students.
Ah, okay.
That's Jesse. It's Bob.
Let me see.
What do you mean?
All right.
This is the first one.
First one? Okay, let's go. What I'm going to do is I have a look at the denominator here and I notice it's pi on 6. So what we're going to do is we're going to split this up, and I like to draw a box of pi on 6 just next to here because this is our base angle, right? It's good practice that you do this. And I still do this when I'm looking for it. The reason why I write pi on 6 here is because now my mindset is on the 6 times tables. So I'm looking at 6, 12, 18, 24, 30, so on and so forth, right? And I look at this numerator here, this number 7. Which multiple of 6 is it closest to? Which multiple of 6? Well, it's the first one, right? So I would break this up now into 6 pi on 6 plus pi on 6. What that means is that if I simplify this, I've got pi plus pi on 6. So it's much easier to find out where our pivot point is now. Pi, because that's a whole pi, yeah? Where is this pi located? On the left, on the right? Left, because it's odd, okay? It's 1 pi, that's an odd number. So what I'm going to do is I'm going to put down this first. And I notice from here, all I have to do is add pi on 6. Now, pi on 6, is that a big amount or is that a small amount? Small amount, because if you have a look back up here, notice if you're dividing it to more people, more things, right? The slices are going to be smaller, just like a piece of pizza, right? The more people you have that you're sharing it amongst, the smaller the slices will be. If you're only sharing it amongst 3 people, each person is going to get a huge slice. Does that make sense?
Yes, sir.
Excellent. So what we're going to do is we're going to add on, and it seems that this section here is where 7 pi on 6 is. So you draw a line, and then you write your angle, 7 pi on 6. Okay. We're going to work across here. So our next example is 2 pi on 3. What I like to do is write the base angle. Again, that's pi on 3. And put it in a box. What are we going to split this up into now? How are we going to rewrite this so it splits up into 2 ideas? Sorry?
Pi over 3 plus pi over 3.
Pi over 3 plus pi. I want to find the nearest whole pi. So nearest multiple of 3. So I either go 3, 6, 9, 12, so on and so forth. What's it closest to? 3, right? Because the next one that we have down is 0, right? And then -3, -6, so on and so forth. So 3 is our closest multiple. That means we're going to break it up into 3 pi on 3. But how do I get back to 2 pi? Do I add or do I subtract?
Add a negative number.
Yeah, add a negative number. So that's the same as a subtraction. Right? So if you have a look here, that's the same as pi minus pi on 3. We know where pi is located. that means we're going to pivot from the left point here. And if we're subtracting, then are we going up in a clockwise direction, or are we going down in an anti-clockwise?
Clockwise.
Clockwise, we're gonna go this direction, right? Pi on 3, is that a big amount or a small amount that we're pivoting?
Small.
Big amount. So this section here,
Small.
sorry,
How do you tell if it's a big amount or small amount?
have a look at the top half, yeah? If you're dividing it with 3 people, you split it twice. 1, 2, 3. Right? If it's pi on 6, then you would split it up into smaller pieces. Does
I
that-
understand. Thank you, sir.
Excellent. You're welcome. So let's have a look at the next example. So we know where this is located now on the unit circle. That's where it's located. That's where it's located for 7 pi on 6. Okay. How would we split it up for this one? First of all, I know it's pi on 6 as the base. What's the closest multiple of 6 to negative 11?
2.
Did someone say something? Ben? Was that you? Yep. What's the closest multiple to negative 11?
He said 12. He's too
Ah,
quiet.
okay, cool. Positive 12 or negative 12?
Negative.
Okay, cool. Thank you. So we're going to break it up into negative 12 pi and 6. And are we going to add or subtract pi and 6? I can't hear anyone, so I'm just going to say add, right? This is the same as negative 2 pi plus pi on 6. Where is negative 2 pi located? Left or right? Left side or right side? Right side, because it's even. Yes. So we're going to pop it here. We're going to add pi on 6. So is that going anti-clockwise or is it going clockwise? Anti-clockwise. Nice. So here it is. This position right here is negative 11 pi over 6. That's all we needed. Cool. Last but not least, I'll just fly through this example here. I know that pi on 3 is the base angle. Closest multiple, so I'm thinking of my 3 times tables. Closest multiple would be either 24, negative 24, or negative 20. Which ones are closer to? 21. Okay.
Yeah.
So we're going to break this up now to negative 21 pi. And to get to negative 22, we're not going to add, we're going to subtract another pi on 3. Okay, I'll just write this again so it doesn't look dodgy. There you go. If you simplify this, what's 21 divided by 3?
7.
7 pi, negative 7 pi minus pi on 3. And negative 7 pi is located on the left or the right?
Right.
It's an odd pi.
Left.
Left, thank you. Excellent. And are we going, what does this minus mean? Are we going clockwise or are we going anti-clockwise if we subtract?
Anti-clockwise. It's clockwise.
Clockwise, yeah. So negative direction. I probably should have made a note on that. Yeah. Where should I make a note for that? For angles. Okay, maybe I'll do that on the first page. Clockwise, negative direction for angles. Anti-clockwise. Oops. Anti-clockwise. Oops. This is the positive direction for angles. Yeah, I don't like saying up or down. The reason being is because if you have a look at where we're pivoting here, if I say we're going up, that's the negative direction, yeah? But then if you're over here, the negative direction is this way, right? So I like to say either clockwise or anti-clockwise, okay? So yes, if it's negative, we're going clockwise. So we're going to go clockwise by pi on 3. Is that a big amount or a small amount?
Small. Big.
Big, thank you. Because we're only splitting it up into 3 pieces. Yar. So there we are. That's our location for negative 22 pi over 3. Essentially, all we're doing is basically dancing around the circle. Yeah. Whenever we're finding these angles here, we're just dancing or running around the circle. Let's put all of our knowledge now into account, because each of these things here, we're going to have to start looking at the cast symbol as well. I've put up these examples. I think I've put them up on Compass. And so if you look on Compass, you should be able to see these examples on there. What I'd like you to do is hop on to Compass and draw these out. And we'll probably finish up here for today in terms of the lesson, right? We're going to finish off with this exercise here to just basically summarize everything that I've taught so far. I'll go back on to here. There's a couple of things I'll just explain. We know now how to locate where these angles are on the unit circle, right? The other thing that I want you to write down is what your base angle is. So that's an easy thing, right? We know how to write pi on 3 because we can see it's basically I'm drawing your eyes to the denominator. The next thing is, well, what concept of the trig ratio are we finding of the unit circle or from the unit circle? Is it the x value, is it the y value, or is it the gradient? How can we tell?
Oh, sine, cos, and tan.
Sine, cos, or tan. Okay, so what does sine measure again?
Y.
Okay, cool. Y value, okay. Sine measures the y value. What about if we're looking at the x value? Okay. And the gradient? Amazing. Okay, so basically when you start looking through each of these questions here, you could instantly recognize that, oh, here we're actually just looking at the y value. I'll start looking at this. I'll start by doing a few examples for you. Okay, maybe I'll do one from sine, cos, and tan. We have to find the location on the unit circle. Pi on 3. Well, that's in the first quadrant. We always start from here, 0. We go, it's a positive pi on 3. So we're going anti-clockwise. And since it's pi on 3, is it a big piece or a small piece that we're pivoting by?
Big.
Big piece, nice. We're getting the gist of it. I'm also gonna ask you for part number 4 here. Is the value positive or negative? And how do we know?
It's positive.
It's positive, why?
Because it's going up.
It's going up. Yep. So there's a few ways you can look at it. You can think about the cast, right? And it's in your A quadrant. So here, everything is positive, right? Everything's happy. It's sunshine and rainbows. So it's going to be positive. The other way that you can look at it as well is, well, what's our Y value at this point? You can see our Y value is here. This y-axis is +1 right here. So it's just under +1. So it's going to be a positive value. Okay. All right, let's go through this. I should have wrote this in a different order. We'll go 1, 2, 3. Sorry. 1, 2, 3, then 4. Anywho, cos. First thing we see is cos. What are we measuring? X, Y, or the gradient?
X.
X value, okay. What color was I using? Here, X value. What's our base angle? Pi 6. Yep. What is our... Well, actually, let's find where this is located. So see how it's 5 pi and 6. What's the closest multiple that it's located to?
6.
6. So 6 pi on 6. That's located over here. All right, 6 pi on 6 is 1, right? 1 pi. So it's located on the left. And to get back to 5 pi on 6, do we go anti-clockwise or do we go clockwise?
Clockwise.
Clockwise. We're going to land in this quadrant here. So here's 5 pi on 6 because pi on 6, we're going by a small amount. More people, smaller slices. Okay, so that's where 5 pi on 6 is. Last thing, is it positive or negative here?
So what's that?
Negative.
Negative.
Sir,
Why?
because it's on the left side of the plane.
Yep,
And it's because the X value is on the left side of the plane.
What is
yep.
it?
We're on the negative part of the x-axis. Or you can say we're in the cos quadrant. We're in the C, oh, sorry, C quadrant? Is this the C quadrant here? C, A quadrant. Okay, we're in the S quadrant. There you go. So there's different ways of doing it. Cool. Last example. Tan measure Z. What does tan measure? Gradient.
Gradient.
Gradient, thank you. What's our closest multiple of 3?
3. 3, so. Negative.
-3? Okay, so -3 pi and 3, that's equal to negative pi. So are we on the left or on the right?
Right. I mean, right, that's.
Right
Right.
side. Where's negative pi located? Is that's -1, yeah?
Yeah.
So that's on the left. Yes, thank you. So here is where we're pivoting from. No, I forgot. Here's the angle. Right. And to get back to negative pi and 2, we're at -3 pi and 3, yeah? And this is where I actually need to write it out. So I'll do this as a little calculation here. -3 pi and 3. To get back to -2, I need to plus or minus. Okay, cool. So are we going clockwise or anti-clockwise? Anti-clockwise, good. By a big piece or a small piece? Big. All right, there it is. That's where the angle is located. And which quadrant are we in?
T.
T. We're calculating tan, so that's Allied territory. We're going to have a positive outcome. Okay, so what I'd like you to do just in the next couple of minutes or for homework is to go through each of these examples here and basically find where it is and figure out if it's positive or negative. Okay, so find the location and figure out if it's positive or negative. Cool. But if you go through each of these and do them all, just like how I've done it in these examples here, it will give you better understanding. So the idea is not to get through these questions as fast as possible. It's to understand why you do what you do and what basically, what does this mean here? We're finding the y value at this angle, okay? The y value at this angle. We're trying to find the gradient here. So what is this gradient? It's a positive gradient, yeah? Because you can see it's facing this way. What are we finding here? We're finding the x value at this angle. So at this point here, what's the x coordinate? All right, what's the x coordinate? What can you say about the x coordinate here? What do you notice? What's this x value here?
Negative.
So 0.
1, right?
Negative.
Yep, -1 is right here. You can see it's pretty close, yeah?
More than -1.
Yes, it's very close to -1. So if I type in cos of 5 pi on 6 here, make sure your calculator is in radians, by the way. You can see that's very close to -1. -0.87, or basically just -0.9, yeah? Every round. Okay, so that's pretty much it. You can go through those examples there, try them. And for tomorrow, there's going to be no class, right?
Yes.
But I want to continue on so you can actually figure out what these values are going to equal to. Okay, there's a couple of ways to teach this. This is one of the ways, but I might put up a few links for you so you can watch perhaps over the weekend. So you can have a look and see which way works for you. Okay, so we're going to actually find out exact values, which is exercise 14F. So we're going to start 14F next week. We've basically gotten up to 14E. Okay. All right.
Is there anything you'd like to say to Mr. Jim?
Thank you so much.
You're welcome. All right. Thanks, Miss Scott. And thanks, everyone. I'll catch you in next week.